Hey, welcome to another episode of HashWise Convo. Today, joining us is Ishaan from Eigenlayer. We are thrilled to have you here, sir. How is it going?
Hey, doing great. Nice to meet you, Homer and Andy. Excited to be here.
Nice to meet you too,
Hi.
man. Thanks for your time. Maybe before we dive in, could you a little bit introduce yourself to our listeners?
Yeah, absolutely. I'm Ishaan. I'm a protocol researcher at Eigenlayer. There, I focus on AVSs and AVS consumers, and just focus on what does the next generation of these AVSs or actively validated services look like.
Awesome. You touched it a bit. Maybe we can start right from the bottom. Give us like short pitch on Eigenlayer. Like what is it? Why people should be excited about Eigenlayer?
Yeah, definitely. So I'll start off with Ethereum, right? I think Ethereum is very exciting to me because it enables anyone to create like a financial experiment on chain where no one has to trust the creator. You're able to just look at the code that's running. You can verify it on Etherscan, and then you don't have to know anything about the actual person who's created this smart contract. But you can deposit capital in it, and it drastically accelerates the rate of innovation of finance because there's no more barrier of trust. So it's effectively decoupling software and trust. Now, Eigenlayer, what it seeks to do is it goes a step beyond this and says, okay, what if let's go beyond finance? What if we could do decouple trust and software for any arbitrary piece of software? So this means if you're running an AI model, if you are pulling off-chain data about like who won the most recent sports betting application, uh, any arbitrary piece of software, Eigenlayer seeks to decouple the portion of software and trust. And I think that's super cool because it just again like accelerates what does the progress of innovation look like.
Yeah, that
And
makes. Go ahead.
maybe if you look at it via this lens, like what are the most interesting like AVSs, these apps that are building on Eigenlayer? Like, what are you excited about? Who is building whatever the most interesting app?
Yeah, definitely. So let's take a step back and understand what Eigenlayer is, right? Eigenlayer is a developer platform that enables anyone to create any arbitrary software with a decentralized set of operators who are economically aligned to their protocol. And that goes back to the any arbitrary software that I was talking about earlier. We call these like applications that rely on these operators as AVSs or actively validated services. So you mentioned what can possibly be built as an AVS. We're seeing that Infura is building a decentralized RPC network. We're seeing Layer Zero is building a crypto economically secure bridge so that you don't need to trust their decentralized set of validators, uh, which could which could just be like a two of two multisig theoretically, but instead they can have economic security backing them, so that economic security backing them, and then you can actually verify and slash validators if your message is censored or delivered incorrectly. Lots of cool things on MEV. Sorella is building a MEV reducing AMM by running an auction and delivering this the MEV that comes through this back to the LPs on Uniswap. So definitely a wide range of potential projects out there, and all of them are very cool.
Yeah, basically, put it in a way like what Eigenlayer is trying to solve is basically to allow anyone to tap into the security that Ethereum provides. Am I correct here? Like, is this like the basic line, let's say?
Yeah, absolutely. I think uh, the under like if you I spoke about this at a very high level beforehand about what is Eigenlayer doing about accelerating and decoupling innovation and trust. But the way it's able to do that is you need a solid base layer of trust. And so where can you find the most trust available today? And you look at Ethereum. Ethereum has a lot of trust baked in, the crypto economic trust baked in this protocol with the Ethereum asset. And this Ethereum asset is really powerful. ETH as an asset is very powerful, but right now it's just being used for validators who are looking at the Ethereum network and they're saying, hey, this is like, these are valid state transitions, these are not. And sometimes if there's a fork in the network, they're deciding what's the canonical fork by using the longest chain rule. And I think you have this incredibly decentralized network of validators and this immensely high market cap asset seems, I don't want to say a waste, but not living up to its full potential of what we can do with this source of trust. And so what Eigenlayer does is it enables restaking or repurposing this ETH to not just be used for validating the Ethereum network, but to look to uh, create trust for any arbitrary piece of software in the form of an AVS. And that's what restaking is.
Yeah, that's
And
cool.
is it only on for apps that are built on Ethereum, or is it also cross-chain? Like, if I built an app on random L2 or I don't know in Cosmos or wherever, can I also take this security from Eigenlayer? Where does it
Yeah,
need to be built?
yeah, absolutely. So I'll say you separate the application from this like AVS, right? The AVS is constitutes of any of these of these operators, and these operators can run any arbitrary software. So if these operators are running, like you want these operators to exist on the Cosmos chain, then you can have these operators run the node software for the Cosmos, like the specific Cosmos chain that you want them to run. And then your AVS can effectively exist as the Cosmos chain, or the operators can interact with that said Cosmos chain very seamlessly. We're seeing a lot of teams do this. And you can also have different AVSs, like different smart contracts on different chains consume outputs from these AVSs. We're seeing Lagrange, for example. They're a zero knowledge coprocessor that effectively performs like what would be gas expensive SQL queries, but they're doing this on so that you can just get more information about the past data uh, on any chain, or like past states on any chain. And then they're pushing this, you can call out to them on base or from other L2s.
So
So,
basically,
hmm,
sorry, Andy.
yeah, go.
Basically, does it work like that the AVS is able to tap into the history of the blockchain, find out the data that you want, and only prove on chain the output? Like, for example, the DeFi protocol want to know at what time in the history happened something, you know? So the data will be like the output will be it happened 10 times, or for example, the whenever the gas was above 50 way in the history, or I don't know, or how many people interact with this smart contract at specific time. So there is only like one proof on chain, like the output for the ABSs, or how can I imagine it that it's working?
Yeah, that's exactly right. Is that they're looking at past data, and the way that zero knowledge coprocessors like Lagrange and Brevis work is that they create a verifiable data set constructed of the blockchain state over many different blocks. So they're saying, okay, we want to, let's say you make a request on Uniswap, and you say, I want to look at the Uniswap LP balances over time from like the origin block till now. And so Lagrange will create a verifiable data set over this that collects some subset of the blockchain information that makes it easier to calculate rather than how it's currently represented on chain, stores this in a relational database, and then they perform SQL queries and then make ZK proofs of these SQL queries on and post those on chain, and then alongside the outputs of those SQL queries. And what this enables is effectively looking at any past state that you would want to look at, but it's currently too gas expensive to compute. An example of this is, let's say you have let's say you have an AMM, right? And you want to look at the past 30 days of volume for a specific trader, so you can give them a custom fee if they're a high value trader. It's currently really hard to do this on chain because you need to keep a running track and expire the volume after 30 days for every single trader. It's just too gas inefficient. But if you can make these queries in real time, just like a centralized exchange would, now you have this capability on chain, which is pretty cool.
Yeah, we are going to definitely discuss this further, but let's step back a bit and let's give one example. You mentioned layer 0, right? And the crypto economic security in this case. So let's say you have a bridge backed by layer 0 and by the AVS built upon Eigenlayer, and there are like 10 operators. Every operator has, so let's count it easy, so $10 million. So in overall,
Sure.
we have $100 million. What happens if any transaction is nominal, like higher than the $100 million? Would be like all these operators incentivized to, disrupt the AVS itself, or, to act like dishonest, or this is like the case that I'm like curious. What happened then?
Yeah, absolutely. So let's see what the operators can potentially do, right? The operators are incentivized to take this let's say $200 million transaction and deliver it to themselves. Well, what is this signed message? The signed message that a user sends says, okay, I want to deliver $100 million from from my address to this other address. And then I'm going to cryptographically sign this message with my private key. So the worst thing that these operators can do is they can not deliver the message. What they can't do is they can't change the address and then apply my cryptographic signature on it again because they don't have access to my private key. And then relay that message to the destination chain. So the worst thing that they can do is censor or censor the message, or if they try to do like a different message, then it's simply it won't be signed with my private key. And when one operator tries to do this, let's say tries to change the message or censor the message, then what the other operators can do is they can see, hey, we see that this first operator is trying to censor or trying to deliver an invalid message, and so we're going to slash them as a result.
Okay, then my lead question from this would be like, is crypto economic security a meme after all? Like, is really necessary to have crypto economic security in this case?
Yeah. So I think that effectively right now what you want to do is you want to ensure that you don't need to just trust these decentralized set of validators, right? Think if like these validators are if these what the validators can do right now is that they can collude and try to censor a message. And the end state of a network, what we want to build, is something that, yes, it's safe, but it's also live. And so if what we can do is make sure that uh, if crypto economic security exists, then it enables us to actively reward and punish reward for correct actions and punish for censorship or potential incorrect actions. That uh, yeah, sorry, punish for incorrect actions like censorship and delivering incorrect messages. And so what you can do is you can actually operate in much faster like real time than you could if you were uh, just reliant on social consensus. If you were just reliant on social consensus, then what it would require is for you to effectively eject the operator from this operator set and then include new operators if necessary. Whereas if you have a slashing mechanism that's pre-built, you can move much faster. And so you can almost think of crypto economic security as another layer on the cake that enables us to progress faster as a society, right? You can have these like social consensus as the universal backstop layer. If anything happens, then we can just, let's say, fork Ethereum and make a hard fork. But the ideal is to make hard forks as rare as possible. Instead, what you want to do is rely on other means. So you have crypto economic security as a layer on top, and there are many things that you can do. And this says that okay, now these validators have something at stake, so they're more likely to act honestly. So we can move faster as a result and slash them if not. And I think zero knowledge proofs as even a layer on top of this, which is saying now we are making it effectively impossible for you impossible for you to act honestly because you have to create a ZK validity proof that whatever actions you did are honest. And so that enables us to move even faster. And now the reason you have different layers of the cake is because maybe there are some things you can't do with zero knowledge proofs that you can do with crypto economic security. And a great example of this is solving censorship resistance or like the data availability problem. If you try to solve the data availability fisherman's problem, you can't do that with a ZK proof because it's not something that is just it's not something that is uh, canonically true. It's not something that is uh, just objectively true based off of math and numbers. And so you do need to use crypto economic security there. And same thing with, yeah, there are a few other examples. Happy to talk more.
Mhm. Yeah, thanks a lot. Maybe let's take it a little bit back. And
Mhm.
Homer, an example of this layer zero bridge that has, let's say, 100 million of dollars of the economic security. And maybe what I wanted to ask is, like in Eigenlayer, currently there is like $16 billion of the economic security locked. And you said there is a lot of applications like bridges and data availability layer and so on and so on that want to tap into the security. And my question is like, how many of these AVSs are actually coming to market? How many of them do you see? And what is like the market size that they want? Like, what kind of security do they seek? Do they want 10 million, 100 million, 1 billion? What's kind of their choice?
Yeah, definitely. So right now we have 20 AVSs on mainnet, and I think a lot of people have talked about what is the demand for economic security right now, and that's still an emerging idea in these protocols' heads of like how much economic security is enough because in order to do that you need to calculate what is the potential profit from corruption or another way of doing this is if we were to look at the potential harm caused by users from our AVS from failing, how much would we need to redistribute back to those users? And that gives a notion of strong crypto economic security. And I think still unclear about exact numbers. Uh, but what we're seeing is that a lot of projects wouldn't be existing without this easy access to crypto economic security. And we see this like if you have a chain, it's fairly easy to make a fairly easy to say, oh, we'll just make a token and have everyone hold it, hold this token as a staking token. But what we're seeing is that you have net new projects, yeah, net sorry, net new projects like policy layers or auctions that are running adjacent to the Ethereum main network being built up that you wouldn't see otherwise. And I think the design space is just starting to emerge, and it could be potentially so much bigger than it currently is. And we already are seeing around 150 to 200 projects also further in development on the stack.
Great, great. Yeah, as you already said, like we see a bunch of use cases, like in general, such as shared sequencing, oracles, roll up as a service, backing by the Ethereum or the restaked ETH from Eigenlayer, DA, fast finality, interoperability solutions, etc. What would you say that we are still missing? Like, what's next? What has not been built yet upon Eigenlayer until now?
Yeah, that's a good question. Hmm. I think one thing that remains to be seen is a primitive for censorship resistance and a primitive for privacy. I think that the Ethereum network as a whole uh, is is not where it potentially could be. And I say these as primitives that could help Ethereum network as a whole, but also just like broadly for other decentralized networks. Is that right now our approach as a system to censorship resistance is saying, hey, if you have enough solo validators, then your transaction will get included eventually. But we saw with like Max Resnick and the special mechanism group that they were able to censor a block and effectively make sure it was empty. The ideal situation is that that's never able to happen so that you can run more time sensitive applications on chain, whether that be auctions or anything else. And I think that's that's super cool. This censorship resistance component also like plays into Mev boost. If you want to enshrine like a proposer builder separation on chain, then you need to make sure, because everything follows this like last look problem and everyone's trying to get it into the last 10 100 milliseconds, that you do need censorship resistance at a very low time latency. So I think those two primitives could be super cool.
That's a really interesting answer. Thanks for that. Can you like imagine censorship resistant layer 2 built on Eigenlayer as a rollup, for example, or censorship resistance chain, sovereign chain on Cosmos ecosystem, for example? Like, do you think this is the future where we are heading?
My hope is that maybe for some maybe it starts off as a layer 2, but my hope is that we can embed low time frame censorship resistance into Ethereum mainnet itself. And I think one thing that's underrated about Eigenlayer is you can have Eigenlayer serve as a testing ground for these, testing ground for changes to the core protocol. If you have or Ethereum validators, many of which also run Eigenlayer operators, and have incentivized them to run these arbitrary sidecars. Theoretically, Mev Boost could be an AVS. Uh, then you can effectively have like 10, 20, 50% of the Ethereum validator set saying, okay, we're running this like sidecar. It actually seems to be pretty useful. Maybe we should consider enshrining it on chain. And now you don't have a whole process of, we need to make sure everything is done exactly right before we deploy it onto mainnet. But instead of more ship like break fast or like ship fast and break things model, where you can have these things running as optional sidecars. And if it doesn't work, that's okay. Then you just scrap it. But if it does work, you continue iterating until you feel like you're at a place that makes sense, and then you can enshrine it.
Yeah, that's super cool thought experiment. Thanks. Maybe let's get also to those L2s that are built on EigenDA actually, because
Mhm.
we have some super cool new stuff like Mega ETH and so on. And I
Yeah.
think again Eigenlayer that built EigenDA as the
Mhm.
first primitive of Eigenlayer cemented itself as like the DA for Ethereum rollups. And there has been some beef between Eigenlayer and Celestia and other providers. Like, what exactly does EigenDA differently, and why
Mhm.
did like Mega ETH and these Ethereum rollup ecosystems choose EigenDA?
Yeah, yeah, absolutely. So I think EigenDA has a few things going for it. One is hyperscalability, and two is Ethereum alignment slash crypto economic strength, which is particularly useful for rollups. And this is not meant to be a knock on Celestia by any means. They're very smart people building incredible things. Uh, yeah, but if you look at the EigenDA versus Celestia architectures, it boils down to this: Celestia is a blockchain, EigenDA is not a blockchain. And what that means is that we don't have to do things like consensus that take a lot of time and energy. Instead, we can just focus on having nodes store data, which is the whole purpose of data availability, right? They store it and then they publish it if someone asks them for data. And if we're not a blockchain, then that means that every node can doesn't have to store every piece of information out there. Instead, you only have to store. Let's say there are n nodes in the network. They're all hosting things equally. You do one data replication factor of maybe 3. Then you need to host 3/n things in the network instead of n pieces of information in the network. And I think that's super powerful because it enables horizontal scaling with the number of nodes in the network. And that's really the core innovation behind EigenDA. And it's what enables us to get to, I think we're at 15 megabytes per second. And I don't know the numbers for competitors or Ethereum for off the top of my head, but it's on the order from 10 to 100 times more than anyone else, which I think that's exciting, right? It's like now you can just have this specialization of labor or DA, and then let Ethereum focus on settlement, and then have these rollups focus on execution. So these networks can be hyper optimized for the things that they're best at. And when rollups focus on execution like MegaETH has, then they can scale execution far beyond like what currently exists. Uh, I believe like they have 10 millisecond block times and a crazy number of TPS. I believe it's around 1,000, but I'm not 100% confident on those numbers. So don't quote me on that.
Yeah, it should be 100,000. What I know, but I'm not sure as well. But maybe let's talk about Ethereum for now, right? Because EigenDA could solve the DA layer. Rollups will
Mhm,
solve the execution layer. What's there
mhm.
left for Ethereum itself?
Yeah, yeah. I think it goes back to that source of trust that we talked about. I think there's immense value in being the source of trust and this like base layer that everyone settles down to, because what is Ethereum's biggest strength is it has the most decentralized validator network that is currently in long time frames censorship resistant, because no matter what you do, you cannot break the Ethereum. It's made so that nation states are unable to tear down the Ethereum network, and I think that on its own is very powerful. Uh, right now, if you look at any other network besides Bitcoin, which doesn't have Turing completeness, uh, the problem with those is that the economics don't work out for stakers unless they're delegated massive amounts of stake. And I think that's okay for bootstrapping an ecosystem, but long term, unless you have this like actually decentralized network of validators, all who are running on their own capital, or capital that's delegated to them not by just one centralized party, then you can be confident that this network can and will run forever, and that's what everyone needs to inherit. And so we should just continue, like Ethereum should continue optimizing for that. Uh, there's also this talk about ETH being money. Frankly, I don't have intelligent thoughts there. Yeah, yeah, not sure what that means. I need to think more about that.
Okay, but where you absolutely have intelligent thought is where Eigen play its role inside the Eigenlayer ecosystem.
Sorry, can you repeat
Yeah,
the question? I'm
absolutely.
not sure I understand.
I will say it again and more clearly. What Eigen like play role in this in Eigenlayer ecosystem?
Okay, okay. So, what is Eigenlayer's role in Ethereum?
No,
Like
no,
Eigen
the
token.
role the role
Oh,
of the
okay.
Eigen token. Yeah.
Sure, sure, sure. Makes sense. Makes sense. Yeah, yeah. So I think Ethereum's, again, like I said, very powerful because it enables us to it's doing these like objective computations on the state transitions, and then these intersubjective consensus agreements on what chain is the canonical chain. Sometimes that means just looking at what is the longest chain. In the event of a hard fork like the merge, it means choosing and moving to a different portion, like different chain altogether. Uh, Now, Vitalik wrote this incredible blog post called "Don't Overload Ethereum's Social Consensus," and that says it's okay to use the Ethereum validator set and ETH as an asset for objective verifications, because that's just something a computer can do, and these validators don't need to act, like the humans behind it don't need to get involved. Now, what gets complicated is if these like the Ethereum validator set is actually needs to be making decisions. And so what Eigenlayer does with restaking is that it enables us to look at any arbitrary software that is purely objective. Uh, yeah, purely objective pieces of software. And so this means like going back to that like ZK rollup stuff we were talking about, or that zero knowledge proof stuff we were talking about, right? Is what is purely objective can be quantified by numbers. That's what restaking is really good at. But now, how can we solve for things like data availability or censorship or oracle prices, which don't have necessarily clear answers? Uh, and the way to do that is by using intersubjectivity. And so, what intersubjective means is that it's anything that is collectively agreed upon as true by a reasonable group of people, but is not necessarily objective and shown on chain. And so examples of this, like I talked about, are data availability. If you are a node, if you're looking at a DA node, you can say, is this node actually giving me the data that I requested? Or are they not responding to my requests? And it's hard to like make a non-existence proof on chain that they're not responding to your requests, but any set of nodes can agree that this node is unresponsive, and that is called intersubjective agreement. Another example is price oracles. There is no canonical price of Bitcoin on chain. Maybe you can say Uniswap v3 is the best price, but that's there are other exchanges out there, and maybe Uniswap isn't the canonical. You want to use a median of different exchanges, and so what an intersubjective quorum could look at is say we're going to look at the five most highest exchanges in terms of volume and take a median of their prices, and that is going to be the price of Bitcoin. So now, if someone says the price of Bitcoin is $60,000 instead of, I think right now it's at 95, 98. So then you could say, okay, that was actually a lie, and you can slash them for doing so. So what Eigen does as a token is it's this just it enables intersubjective uh, intersubjective staking rather than just uh, objective agreements with restaking.
Okay. Okay. Cool. Thanks a lot. Now maybe let's jump into the DeFi, because we have many different topics that we can ask you. The first would be the Uni V4 is coming, the customizable AMMs that allow basically developers to come up with their own like AM made custom. So what are the functionalities that could bring the AVS built on Eigenlayer to Uni V4 hooks, for example?
Yeah, absolutely. I think there's a lot of fun things that you can do with Uniswap v4 and hooks and Eigenlayer. And the reason for this is that Uniswap v4 hooks allow you to effectively include any arbitrary software so that you can like call any arbitrary software before, let's say, a swap function or an add LP or remove LP function, which is pretty cool. But what it does not, what you're unable to do is call out like off-chain software. It has to be a smart contract. What you're doing uh, with these hooks, and if you're calling out to an Eigenlayer AVS, then you can actually include any off-chain software as well or off-chain operator networks. And some examples of this is, let's say you wanted to replicate CowSwap, where you have solvers who are matching these coincidence of wants, where one trader wants to buy one ETH with USDC, and another trader wants to sell one ETH for some USDC. You can match these together so that they're not paying any fees to LPs. Both of them are actually getting better prices, and now, because they're getting better prices, more traders want to choose this venue. And the way you would do that is you could effectively aggregate these trades and share to a decentralized network of operators who are effectively solving or trying to find the best coincidence of wants algorithm and selling the rest to the Uniswap v4 pool. I think this is super cool because it effectively enables you to replicate any uh, any type of exchange on chain rather than rather than just what is available with smart contracts. And you need an off-chain operator because without it, how are you going to? You can't make the optimal algorithm in a smart contract to connect these coincidence of wants or outsource to off-chain liquidity as necessary. Another example, and I mentioned this earlier, is what Sorella is doing. And Sorella, what they want to do is remove this concept of loss versus rebalancing and redeliver value to LPs. What loss versus rebalancing or lever is that there's an arbitrage opportunity between on-chain and off-chain exchanges. Off-chain exchanges operate every millisecond effectively. On-chain exchanges are operating every 12 seconds with every Ethereum block. Let's say the price of Ethereum is 3,500, and then you have a volatile block and it changes to 3,600 on Binance or the off-chain exchange. Now on Uniswap or any on-chain exchange, it's still 3,500. So an arbitrager is going to come in and like effectively arbitrage it for $100. Now this value is effectively being extracted from LPs. But if you run an auction for this first swap, this arbitrage swap, through a pool, then you can give those proceeds of the auction back to the LPs. And now they're losing significantly less money. If you have a competitive auction, could be anywhere from like 90 to 99% of the lever actually goes back to the LPs. And I think that's a like now you can have more liquidity being moved on chain because they're not effectively not getting scammed every not scammed but like arbitraged against every 12 seconds, which is much more powerful and could lead to profitable LPs again.
Would be this usable on layer 2s as well? For example, Mega ETH, because their blocks will be like 100 millisecond, let's say. So would be this usable by layer 2 or high throughput layer 2 as well?
Yeah, I think that for Mega ETH, you have to. It's definitely usable. The question is, does this design make the most sense? If you're being arbed against every 10 milliseconds, the price differences aren't as significant. So I don't know if it makes the most sense. Uh, you might experiment with other designs. Unclear what that looks like. I could still see something like uh, a coincidence of wants replicating AMM existing on Mega ETH, or potentially a dark pool style, a dark pool style AMM existing on Mega ETH. I think both of those could be more interesting use cases on a very fast L2.
Yeah, and as you talked about the Sorella, I think, and the Unichain, Uniswap specifically, I think Uniswap builds the Unichain where the thought is exactly taking back MEV and giving it back to the LPs or the users. Do you know specifics if they are using the Sorella or they're using some other solution?
Yeah. They haven't released more information on how they want to deliver, like reduce MEV and give it back to users. But they are experimenting with a few different tactics, right? One thing they're considering doing is making sure that okay, all transactions will go through, and that sorry, let me yeah. So one thing that Dan Robinson mentioned is that uh, as a possibility is bringing these auctions in house by effectively saying using this priority gas as this priority gas as a way to uh, effectively do an auction. To do an auction. And how this would work is that the sequencer can make the priority fee visible to smart contracts that any transaction is operating with against. And so let's say I'm making a swap on Unichain and I want to set a priority fee because I want to arbitrage. Then the smart contract that I'm operating with on Uniswap can say, okay, whatever your priority fee is, I'm going to charge you 99 times that priority fee to my smart contract. And I'm going to deliver that back to LPs. And what you effectively have is that now I, as a solver, I don't want to pay 99 times my priority fee. So instead, what I'm going to do is I'm going to reduce my priority fee to like 1% of what it currently is, and then pay the same effective priority fee. So now if I'm paying the same effective priority fee, 99% of that priority fee will go back to the will go back to the LPs of that smart contract. And what this would look like is it's effectively the same thing done in like on chain itself, where I'm using my priority fee as a way to bid on placement. As a way to bid on the placement of my transaction in the pool. In the pool. And if I have the highest priority fee, then I can get the first swap. I think this is a powerful mechanism. It definitely has some flaws with related to transaction inclusion. If one smart contract has takes in a priority fee and another smart contract does not, uh, and there's competitive space on the network, then that means that my transactions might not get included, which is unfortunate, because let's say one smart contract requires 99x priority fee and another requires 9x priority fee. If anyone wants to pay $100 worth of priority fee, then I would be putting in $1 for this smart contract, versus competitors could put in $10 on that smart contract, and my priority fee just wouldn't get included into the block. Uh, yeah. But and then also some complications related to, like, what if you have a smart transaction that interacts with multiple smart contracts. So I think Sorella's design is definitely the cleanest out there, by pushing this auction off chain, but there are other design spaces, and unclear what Unisol will decide for Unichain.
I thought that the DeFi is ready and done, but there is still hope that we'll see another rise of DeFi wave. So it's great to hear. Thanks a lot.
Yeah,
And
yeah,
now
I'm
more
very
general,
excited.
yeah. Now more general question is like the current state of, let's say, emergency, but the Ethereum is that layer twos are polarizing like people against or pro Ethereum. There are like layer 2 ecosystem, optimistic, ZK, the base rollups are on the rise. Also the native rollups come up here from the DevCon last week. So what's your point of view on this like rollup centric ecosystem or the roadmap? Like, are you still hopeful about Ethereum, or can you feel a bit like some I don't know, like some bad vibe around it?
Yeah, yeah. I'll say two things. One, rollups are great at scaling Ethereum. Two, they've created an absolute mess, not in terms of just chain fragmentation, but also liquidity fragmentation. And as a user with someone whose majority wealth is on chain, yeah, it's an absolute pain to use. And so I think what we need to see is, yes, chain abstraction, which is being worked on by many teams across the stack with intent-based protocols like Cross, and also like general message passing protocols like Layer Zero. But also, stuff needs to be built potentially at the application layer to solve fragmented liquidity. Because right now, if I'm buying 5 figures of any coin that's not Bitcoin, Ether, Sol, or stable, then there's not enough liquidity on any given L2. And so I need to go back to L1 to, yeah, I need to go back to L1 to actually execute this trade. In that case, what was the point? So you need to think, like, how can we solve this problem of liquidity fragmentation? What we need is not just composability between rollups, but also shared state across rollups. And I think that's a much harder problem that still remains to be solved, but a few teams working in that area. I think they're still in stealth, but it's like can't share too much yet, but I think that's one problem that we really need to fix.
Yeah, hopefully Espresso can pull it off. Would be amazing.
Yeah, yeah, definitely.
And my second question at the end is, what excites you the most right now on the market?
Hmm. That's a very good question. I feel like there's a lot of things. So let's see. I'm particularly excited by this shift to intent-based protocols, because I think that what we're seeing is that there's a lot of hacks happening on chain, and I think one of the biggest barriers to like everyone being able to come on chain is you need immensely better security as an industry, and normal users should be able to identify exactly what's going to happen when they sign a transaction or like sign anything in their wallet. And right now what we have is this I sign an arbitrary set of functions that I want to call on chain, and it doesn't we can simulate the transaction, but it doesn't tell us exactly what will happen at the end state with 100% certainty. And Intense, what they do is they say, okay, rather than sign these functions, sign a specific end state that you want to achieve, uh, given certain constraints and preferences. And if every transaction becomes an intent instead that becomes executed optimally by solvers, then you have we can live in a much better on-chain society where there are significantly fewer hacks because you know exactly what is going to happen when you click sign on any message. Uh, and once you go from there, then you're going to see the number of phishing attacks go from like I don't I'm gonna see it like go down by an order of magnitude. You're gonna see the number of hacks that happen because someone sells an NFT that like is actually infected go down by an order of magnitude. I think this is just a UX change that we need to make as an industry, and also but like this doesn't happen overnight by magic. There's a lot of infra that we actually need to have to make it viable with how you're representing intents, how you're sharing intents to solvers, and how you're selecting the winning solver. But I think it's honestly one of the most underrated problems that we need to be solving.
Yeah, fair enough. Fair enough. There's a hope.
Yeah. Make people comfortable storing money on chain.
Yeah,
It's
yeah.
important.
Man, it's been a pleasure having you on the show. Thanks for taking the time to join us. Appreciate.
Thank you, Homer and Andy. It was great getting to talk with you guys.
Thanks. Great.
Thanks a
Yeah.
lot. Have a good
See you
time.
guys.